This is an introduction to graphing of parabolas. Just like you have different forms of equations of line, for example, an equation of a line, the most common is the slope-intercept form, y equals mx plus b. And then you have something called the point slope form, which looks like this, y minus y1 equals slope times x minus x1. So you have slope-intercept, point slope to both equations of lines. Likewise, parabolas have two forms, primary forms, one called standard form and the other called vertex form. And it's really important that in these forms you're familiar with how you manipulate the equations and what changes. So watch very carefully. In standard form, we're going to focus on this, that standard form. I'm going to that website Desmos. I sent a link, it's also right there. So in standard form you have y equals ax squared plus bx plus c. Just a note of explanation. You're like, what's the f of x? The f of x is the function of x. And the function of x is code for what traditionally you would think of as y. So these would be the exact same form of the equation. The function of x, which is y, equals ax squared plus bx plus c. Now watch very carefully. Right here, y equals ax squared plus bx equals c. A is that first term right in front of the x squared. When that is 1, watch what happens when that a becomes a larger number. As a becomes larger, the parabola gets thinner or compresses. When a becomes negative, it switches the other direction. That's important you understand that a negative a switches directions downward, positive a is upward. So in this equation, that's one observation to make, is when a is positive, your parabola faces upward. And when a becomes negative, your parabola faces downward. Another notation, as the value of a increases, either direction, positive or negative, it becomes more compressed. So it becomes more compressed. I'm just going to draw these arrows, which means it gets skinnier as a increases. Let's see what happens when we manipulate b. So I'm going to put a back at 1. Right now b is 0. Now watch what happens. B becomes positive. B becomes negative. So you can see that the b does not change the shape of the parabola. A does. B does not change the shape of the parabola. It moves the position of the vertex. That's important. B moves the position of the vertex. So B influences the movement of the vertex. See what happens when we mess with C. Notice C is simply moving the parabola up and down the y-axis. Watch what happens if I move the vertex and then I move C. Do you see C is just vertical? So C is what's considered the y-intercept. So right now C is 3, and then you take a look here and that parabola intersects the y-axis at 3. C is 0. Now the parabola intersects the y-axis at 0. Or 0. There it is. And if I go down to -4, The parabola now intersects the y-axis at -4. So the C is the y-intercept of the parabola. That's called standard form. Then you have this form called vertex form. Function of x equals a parentheses x minus h squared plus k. What happens here? I'm back at the second Desmos site. Taking a look here. The A, again, influences whether or not the parabola faces upwards or downwards. So A positive faces upwards, A downward is negative. That's in this form. That A, when A is positive, it faces upward. When A is negative, it goes downward. Now, what's up with the H? If you watch carefully, H is the horizontal coordinate of the vertex. K is the vertical position of the vertex. So in this equation, in the vertex form, H is the x position of the vertex and K is the y position of the vertex. Now let's go over some terminology here for parabolas. Basic definition of a parabola. Let's do something more basic. A circle is a set of all points which are equal distance from a center point. That's what defines a circle, equal distance from a center point. A parabola has a straight line called a directrix and a focus, which is a point. And a parabola is the set of all points which are equal distance from both. For example, if I go like this, go from that straight up to the directrix, and I'm going to switch colors here. That same point direct down to the focus. If you look very carefully, the blue and the yellow are equal in length. Let's try another point. I'm just randomly choosing points here. Ready? Go from the directrix at a right angle to that point, and that point to the focus. Once again, you'll notice that those two lengths are exactly equal. One more time. Ready? From another point directly to the directrix at a right angle, and from the focus to the same point. Once again, you will notice that this distance and this distance are the same distance. So by definition, a parabola is a curve where any point on the curve is equal distance to both a focus and a directrix. An axis of symmetry is basically where could you fold the parabola and get the exact same thing on either side. We call that line symmetry. So if I fold along that black line, the red and the blue would match up. That is an axis of symmetry. And the point at which those matching sides meet, that's called the vertex. Now, here's an example of why a parabola is very helpful. So here's called a parabolic mirror. This is a mirrored surface. And because by definition you have a focus point, the sunlight, when it hits the mirror, is all going to be focused on a single focus point. No matter where it hits the mirror, it's going to bounce to the same point. Boom, boom. And reason why that's helpful, that would allow us to concentrate sunlight. Because all these sun rays, no matter where it hits a parabolic mirror, it's going to bounce to a single focus point, which allows us to concentrate sunlight and do all kinds of lovely things. So that's just one usage of a parabola in real life. Graphing parabolas, standard form. This is the most important page in this entire packet. When you're working with standard form, the axis of symmetry is -b over 2a, which is also the x-coordinate of the vertex. And then you plug it in, and the function of that gives you the y-coordinate. Your C is the y-intercept. That's not going to make any sense until we graph a couple of them, but just relax. You need to memorize this page. Over here in vertex form, the axis of symmetry is simply whatever h is, and your vertex is whatever h and k would be. When a parabola opens upward, the y-coordinate of the vertex is considered the minimum. When a parabola opens downward, the y-coordinate of the vertex is considered the maximum. Now we're going to work through a few problems on the worksheet that you sent. It says use the graph to solve the problem, and what it's basically asking for is where does this parabola cross the x-axis? That's called the zeros. First, I want you to notice a couple things in this particular equation. The a is negative. That explains why this faces downward. Also of note that 4 is the c. That's the y-intercept, of which it is. Now it's asking where are your x-intercepts, and your x-intercept is along the x-axis. So you have 2 x-intercept. One of them is at -4, 0, and the other is at 1, 0. Those are called the zeros of the parabola, or also known as the x-intercepts. This would be the y-intercept. So the parabola intercepts the y-axis at 0, 4, and its 2 x-intercepts are these guys. Coming over here, we first see our y-intercept is going to be 10, so if we were to continue extending this parabola, and go way up, it's flying off the graph that's provided, but 10 would be, it would eventually intersect at that point 10, way up there. That would be your y-intercept. And then your 2 x-intercepts are at 2, 0, and 5, 0. Make note that the a is positive, therefore the parabola faces upward. Now this says write the equation in standard form. A couple things about standard form. You're basically getting the entire equation on one side, and then the other side, you're trying to get to 0. So, and as a general rule, you want to try to keep that a positive if at all possible. So here, standard form, ax squared plus bx plus c looks like this. I'm going to minus 15 and bring it over to the other side. So I have 3x squared minus 15 equals 0. In this case, there is no bx to work with, so this would be considered standard form. Over here, you generally want that a to be positive, so I'm going to add x squared to both sides. This becomes 0 equals, you put the x squared first, x squared minus 14, and you're done. That would be considered standard form. Again, there's no bx in this particular case, which is fine. Coming over here, again, you're trying to get 0 on one side, so I'm going to move this 5 over. So we have 4x minus 2x squared minus 5 equals 0. We're not quite done here, because in standard form, you want the x squared to be first. So you're going to simply rearrange it. So I have negative 2x squared plus 4x minus 5 equals 0. That is now in standard form. It's as close as possible to matching that. Now we're going to take a moment to start graphing. This is the page that's most important. Just going to recopy this. I recommend you recopy it in this corner, what I just did. Okay, so we are in standard form. So you already have the 0 there, so we don't need to mess with it. So in this case, I have a x squared plus bx plus c equals 0. And in this case, a is going to be positive 1, b is going to be 3, c, there's nothing there, so technically c would be 0, and we're going to take it from there. Our axis of symmetry, right there, our axis of symmetry is x equals negative b over 2a. This is a line. Super important that you understand that axis of symmetry is a line. It's an x equals line. Here's your equation. Now we're going to plug stuff in. Negative, parentheses, our b is 3, so we put it right there. Over 2a, and our a is 1. So our vertex line is going to be negative 3 over 2. That's our axis of symmetry. And that's going to be x equals, in order to graph it, a mixed number's better, negative 1.5, because it's easier to visualize that. So we're going to go right here at -1.5. So I am over 1 and over 1/2, and then that is my axis of symmetry. X equals -1 and 1/2. Now your vertex means you have to get the y coordinate. So your axis of symmetry, your x coordinate is -1 and 1/2. So here's your equation. ax squared plus bx plus c. And in this case we have x squared plus 3x equals, it's going to be our f of x, or our y. That's what our y is going to be. So if I do -3/2 squared plus 3 times 3/2, that's going to equal our y. Do not freak out with the fractions. Just take it one step at a time. -3/2 times -3/2 is going to be 9/4. Plus, those numerators multiply, so that's going to be 9/2. That's going to equal y. You're like, whoops, we got denominators that are different. Your lowest common denominator is 4. So I'm going to translate 9/2, a little 4 here. 2 goes into 4 twice. Arrow in, arrow out. And that becomes 18/4 equals y. We're just going to keep working it until we get a mixed number. That's going to be 27/4. 4 goes in there 6 times. It's 24 and 3/4. So our vertex is at 6 3/4, and it's positive. So we come up here. We already have our first vertex, which is the x coordinate, and so we just simply go up to 6 3/4. Approximately right there. And that's your vertex. Okay, Eleanor, we're going to backtrack here. And the reason why I caught myself is I know for a fact, I did a little analysis, I know for a fact that this has to face upward because it's positive. And yet, if from this point it goes upward, we're not going to intersect the x-axis. So I know somewhere my math is wrong. This is where you need to watch your signs very carefully. I'm recording this a little late at night, so I missed my mistake. So where we made the mistake was plugging it in right here. Maybe you caught that while you were watching. Is the fact that this is -3/2. Here we square it, it's positive. So this should be 9 over 4 minus 18 over 4 equals y, which makes this negative 9 over 4. 4 goes in there twice with 1 left over, and it is negative 2 1/4. That's what I get for recording videos at 10:30 at night. So this is negative 2 1/4. So our correct vertex is going to be negative 3/2, which we already have, and down 2 1/4. Should be approximately right there. So negative 3 over 2 and negative 2 1/4. Now that's my vertex. Now, how do I get the arms, is where you ask, and that's where we're going to use what's called X-box factoring. And if you had Mrs. Gangle last year, you should recognize this. So we have x squared plus 3x equals 0. And so to put it in standard form, it would look like this: x squared plus 3x plus 0 equals 0. Now, Mrs. Gangle taught you to factor like this. It's called X-box. And in the top, you put whatever A times C is. And in the bottom is B. So we take a look here. Our A is 1, our C is 0. So 1 times 0 is 0. And our B is positive 3. So now we're going to factor, and the way we factor is we ask these two questions. Which two numbers multiply to the top number but add to the bottom number? What multiplies to the top number and adds to the bottom number? So don't overlook your only option here. If we're going to multiply by 0, we have to have a 0. So what two numbers multiply to 0 but add to 3? It would be 0 and 3. Because 0 times 3 is 0, but 0 plus 3 is 3. So that means if we were to factor this, it would look like this. It'd be x minus x plus 0 times x plus 3 equals 0. Therefore, we have x plus 0 equals 0 and x plus 3 equals 0. And you solve. These are called solving for the zeros. X equals 0 or x equals negative 3. So if you were to graph this, these would be your x-intercepts. You come over here, and one of your x-intercepts is 0, and your other is going to be at negative 3. And if you look carefully, ta-da, you now have your parabola. Let me draw that a little bit careful. There it is. If you were to plot this on the Desmos, right here, x squared plus 3x, technically it's plus 0, like this. And you can see on the graph, look very carefully, our vertex is that fractional form right there, negative 1.5 and negative 2.25. And your one intercept, x-intercept, is negative 3, 0, and your other intercept is 0, 0. Let's do another problem like this. So what I'm going to do is I'm going to first put this in that Desmo program so you get kind of a glimpse on how it's done, and then we're going to do the math kind of backwards just so you can see this. So we're graphing x squared minus 4x minus 5. X squared minus 4x minus 5. There's your basic graph. Okay, x squared minus 4x minus 5. Now we're going to use this kind of as a guide so you can kind of see them both here and how they work. Okay, step number 1, we're going to do our axis of symmetry, and our axis of symmetry is going to be x equals negative b over 2a. We plug that in very, very carefully. Our b is going to be negative 4, and our a is 1. So I have here, I'm going to move a little left here, negative 4 over 2, parentheses, there's a 1 there. Double negative makes a positive, so this is going to be 4 over 2, which means our x-axis is x equals 2. So that's going to be our axis of symmetry. X equals 2. Now we're going to find the y-coordinate by plugging it in. Our equation is x squared minus 4x minus 5. So we're going to plug in 2, and that 2 is going to go here and there. So that's 4 minus 8 minus 5. 4 minus 13, that makes that negative 9. So our vertex is going to be over 2 down 9. So our vertex is right there, 2, negative 9. Now we're going to find our zeros. Using Mrs. Gengel's X box. So remember, this top X box is A times C, and the bottom of the X box is simply what B is. Now in this case, our A is 1 and our C is negative 5, so 1 times negative 5 is going to be negative 5. and our b is -4. So we ask ourselves, what two numbers multiply to -5 but add to -4? And those two numbers would be a 1 and a -5. Because 1 times -5 is -5. 1 times -5 is -5. And 1 plus -5 is -4. So that's how you do the little check. So your equation looks like this. X minus 1, plus 1, and x minus 5 equals 0. That's called factoring. Now, just so you know this works, you can always FOIL it back to double check. That's going to be x squared minus 5x plus 1x minus 5, which gets us x squared minus 4x minus 5 equals 0. So you find your zeros. I have x plus 1 equals 0 and x minus 5 equals 0. So my x-intercepts is -1, +5. So you come over here. My x-intercepts are -1, +5, right there. So -1, 0, 5, 0. Now I have my points and I draw through the vertex. You draw as even as possible. Ta-da! On either side of that axis of symmetry. And there is your parabola. Which, if you look very carefully, we already did on Desmos, and it matches. Ready? Let's try another one. So we're going to graph this parabola. X squared plus 2x plus 1 equals 0. Just to get a visual here, we're going to plot this on that Desmo link. So that's x squared plus 2x plus 1 Okay, so you just have a quick visual. We're going to leave that there. We're going to come back to it. Coming over here. Step number 1, our axis of symmetry. Is -b over 2a. Once again, b is going to go right there. That's 2. Your a is going to be 1. So I have -2 over 2 times 1. So our axis of symmetry is at -1. Now to get our vertex, we plug it back in. That 1 goes right there. So -1 parentheses squared plus 2 times -1 plus 1 equals 0. -1 times -1 is +1. Minus 2 plus 1. This is basically 2 minus 2. So our vertex of our parabola is going to be -1, 0. That's our vertex. So our vertex is actually right there. Now, since it's sitting on the x-axis, we don't find the x-intercepts. What we can easily do is we already know our y-intercept is positive 1. So I go positive 1 over here, and then I mirror it over this. And I'm going to just choose one other point to the right. So I'm going to put in 1 and -3 and get an extra point there. So I have x squared plus 2x plus 1. And we're going to put a positive 1. That's where that yellow is. So that's 1 squared plus 2 times 1 plus 1. That's 1 plus 2 plus 1, 4. So I know right here at the positive 1, I'm going up to 4. And then I mirror that the other direction. There you go. Now it's a little bit easier to see the parabola. The parabola looks like this. Which is exactly what we're getting on Desmos. All right, let's take a look here. Now, super important to catch this. Boom, our A is negative, so instantly you know that parabola has to face downward like this. Step 1, axis of symmetry. But we are not in standard form yet. So I'm going to go ahead and move the x squared over to the other side. So I get 0 equals x squared plus 7x plus 18. Now take a close look. Our A is now positive when we do that, so I was mistaken. It goes upwards. Now we're going to find our vertex. Our vertex is negative b over 2a. So that's negative, our b is 7, over 2 times a, which is 1, which means our x vertex is going to be negative 7 over 2. Now we're going to get over here, we're going to find our y. Negative 7 over 2 squared. Okay, I brought this over to Desmo because I don't want you to freak out. I just want you to take a close look here. And it is okay. Notice that vertex going to be a fraction. That is okay. It's always good. Plot it on Desmos first just so you can reassure yourself. Okay, so I'm going to leave that there because we're going to come back to that. So you see that all this messy fraction stuff actually is accurate before we do it. So now I'm going to do 7 times negative 7 over 2 plus 18. This is going to be negative 49 over 4, positive, because negative times a negative is positive. That's going to be negative 49 over 2 plus 18. Our lowest common denominator is 4, so we need to put everything over a 4 here. So it's going to look like this. 49 over 4 doesn't change. We have to double 49, so that's going to be minus 98 over 4. And 18 we need to times by 4 to get it over 4. So plus 72 over 4. Just relax, it's fine. So we're going to do 49 minus 98 plus 72. 49 minus 98 is minus 49 plus 72. That's going to be 23 over 4. Positive. Now, really hard to graph when you have improper fractions, so we're going to change this to a mixed number. So 7, 2 goes into 7 3 times with 1 left over. So this is negative 3 and a half. 4 goes in there 5 times, 3/4. So if you look carefully, our vertex is negative 3 1/2, 5 3/4. Now, just so you know, we haven't completely lost our minds here. If you take a look right there, that's what that point is. I'm holding it, negative 3.5. Do you see it? And positive 5.75, that's our vertex. See, fractions are okay. Don't panic with fractions. Just takes a little bit of footwork. Now, to find your zeros, so to graph this, is negative 3 1/2 and positive 5 3/4. 1, 2, 3, 4, 5. That would be 6, so 3/4 goes about right there. Now, because I know this goes upward, I know that my intercept is positive 18, so it's going to go way up here somewhere, wherever that would be 18. It's kind of flying off the graph here. And then it would just kind of angle it that way as well. And there it would be. See that on Desmos? If I pull this back, you'll see that it intersects at 18 on the x-axis, right there. That's 20, that's 18. Let's go over this word problem here. Usually that's where students have a lot of trouble. So it says the height, y, in feet of a toss in a bocce ball can be modeled by this. So because this is a ball toss, we know that it's going to look something like this. The parabola is going to look something like this. Okay, and I know it faces downward because right there is a negative a. So step one, we're going to graph this. We're going to find our axis of symmetry. Technically, that's plus 0 equals 0. So my axis of symmetry is negative b over 2a. That's negative. Our b is going to be 4 over 2. And the a, what's right in front of the x, is going to be negative 1. So I have negative 4 over negative 2, and of course that just becomes 2. So my axis of symmetry is going to be at positive 2. Now my vertex, I plug it in. I take that 2 and I'm going to plug it in here and there. So I get negative 2 squared plus 4 times 2 plus 0. This is going to be negative 4 plus 8, which of course is 4. So our vertex is going to be at 2, 4. So over 2 up 4, there's our vertex. Now I know that our parabola has to face kind of downwards, so somehow it's going to go like that. We're not quite sure where because we don't know where our intercepts are. So I'm going to come down here. A times C, our A is negative 1, our C is 0. So negative 1 times 0 is going to give us 0. And then our B is simply positive 4. So we ask ourselves, what two numbers are going to multiply to 0, but the same two numbers add to 4? And that would be 4 and 0. So 0 times 4 is 0, but 0 plus 4 is 4. So my intercepts, I have x minus 0 times x plus 4. So x minus 0 equals 0. X plus 4 equals 0. So my intercepts are going to be x equals 0 and x equals negative 4. So I come up here and graph x equals 0 and x equals graphing that on Zemos. There you are. There's 0 and 4 right there. The reason why it is positive 4, not negative 4 is because that's negative right there. So we do this, switches the sign this way, there's your 2 point, and so your parabola is going like this, or your bocce ball is going like this. Whoop. That's how the ball is being tossed. Now, it's asking you 2 questions. Interpret the x-intercepts of the graph of the equation. And notice it's in feet. So our x-intercepts mean if I'm starting at 0 and I end at 4, that means the bocce ball is landing 4 feet away from its place of origin. It starts here and ends up there, and that distance from here to here is 4 feet between the intercepts. It says, how far away does the bocce ball land on the ground? And the answer is 4 feet. Okay, this particular section, the reason why I've switched to this equation, and you might recognize this as the quadratic equation, is because the instructions talk about round to the nearest tenths place. So I instantly know it's decimals. And if we're factoring using decimals, it means we're working in the quadratic equation versus Mrs. Gengel's X-box factoring. Because we only use this X-box factoring when your factors are whole numbers, because you can't do this kind of stuff in your head when you have decimals. So the minute the instructions talks about rounding to the tenths place and implies that decimals are involved, you're using the quadratic equation. Now Mrs. Gengel had a jingle for this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And that's called the quadratic equation. So let's identify our factors here. Our a is negative 1. Our b is 8. Our C is negative 6. So I'm going to take this equation and I'm going to rewrite it where I leave these as blank spaces. You'll see why, because it just makes it easier to plug in. So I'm going to leave blank spaces here. This is called, I called this process a template. So watch what I do. It's going to be negative b plus or minus square root b squared minus 4ac all over 2a. Notice every time I said a letter, I left it blank. Now that I have my blank template, I start plugging stuff in. The b goes here. That's going to be 8, a, negative 1, a goes down here too, and c, that's times negative 6. Okay, now you just need to be very, very careful with the math here. I have negative 8 plus or minus square root. This is 64. Now watch your negative signs here. We've got a negative times another negative. So negative times a negative is a positive times a negative is a negative again. So that's going to be minus. And 6 times 4 is 24. All over negative 2. We're going to do a little bit more math here. So I get negative 8 plus or minus square root, and this is going to be the square root of 64 minus 24, 40 over negative 2. At this point, since negative 40 is not a perfect square, this is where you get to use a decimal. So your calculator, and I'm simply going to do the square root of 40 and round it to the tenths place at 6.3. So I have two versions, because there's always two intercepts because of the plus or minus. So that's going to be negative 8 plus 6.3 over negative 2. And then I'm going to have negative 8 minus 6.3 over negative 2. I don't know if you could hear that in the background. That's my cat asking to leave the room. Give me a second. Let me let her out. Alrighty. So yes, you get to use a calculator. So we have here negative 8 plus 6.3 divided by negative 2 I'm going to do it this way. I'm simply going to go 6.3 minus 8. I think that's a more accurate way of saying it. And it's divided by 2, but remember that's negative 2, so we swap the signs. And so our first x-intercept is going to be 0.85. And this next one, that is negative 8 minus 6.3. So negative 8 minus 6.3. Oh, negative 6.3. Negative minus 6.3. There it is. Divided by 2, and that 2 is negative, so a double negative makes a positive, so 7.15. So, however, just to kind of, so you can visualize this, what this would mean is if you had some sort of graph like this, that this parabola, when it's facing downward, why? Because of this negative sign right there. And the parabola would intersect at 0.85 and 7.15. So somehow we haven't taken the time to find our vertex, but that's how the parabola would have been shaped. We didn't take the time to calculate the vertex in this case because I don't think the instructions asked for that. It just asked for the zeros. Let's do one more. And again, why am I using the quadratic equation? Because the instructions talks about finding it to the tenths place. So copy down the quadratic equation and leave your blanks there. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So that's where a goes. B is going to be 3. And C is going to be negative 2. So I plug this in very carefully. So B is 3. A is negative 2. And C is also negative 2. Keep in mind that's times there. Okay, now we're going to do the math. That's negative 3 plus or minus square root. That's 9. Now watch your signs here. This gets tricky. A negative times a negative is positive. Times another negative is going to swap it back to negative. 4 times 2 is 8. Times 2 again is 16. Okay, I'm hesitating here, Eleanor. Let me go back and take a look at the original instructions here, because there's something here that if we're using this, you're going to end up with something called imaginary numbers. So I am double checking this before I finish this. Okay, I think this was the second to last problem. Just to make sure I copied everything correctly. 19, 19. Okay, approximate the zeros of the function to the nearest tenth when necessary. Negative 2x squared plus 3x minus 2. Okay, the reason why I'm hesitating here, Eleanor, is that I don't see that you have learned anything called imaginary numbers. And the reason why I'm hesitating, so we have negative 3 plus or minus. This is why I'm hesitating, because 9 minus 16 is negative 7. And a long time ago, you probably were taught, like, wait a minute, you can't square root negative numbers. Well, there's something called kinda, which is imaginary number called I. And unfortunately, I don't see any evidence that you've learned that yet. So that's why I'm hesitating to try to explain that to you, because that's an entire number 20 minutes. So I'd like you to go back and put a star by this problem and ask your teacher if he meant to use what's called the imaginary number I there. Because if you haven't seen it before, the imaginary I is involved in this problem because of that negative 7. That's why I hesitated and double-checked everything, because that's introducing a completely new concept there. So put a star by that last problem on your worksheet. That was problem number 19. I hope at least some of this was helpful, even though it was had a couple little typos on it.